Okay, this is Unit 8, Lesson 8. Perimeter and area of rectangles. Now most of you know area and perimeter. What's going to be different in this unit or this lesson is that they are using some fractions. So we got to go back and remember what it means to multiply fractions. But let's look at an example of each of these and what that means with fractions. So we're just going to do a simple rectangle. I'm just going to freehand it, so it may not be perfect here. So let's say I have a side that's 1 1/2 and a side that's 3/4. Okay, well, perimeter is pretty straightforward. I just add these up. So I'm going to have 4 sides. I just have to add each side. So I get 1/2 plus 1/2 plus 3/4 plus 3/4. Remember, I have to do LCM, these common multiple, to get my denominator. So I'm going to convert this. This is equals, it's going to be 4. So multiply 2 times what to get 4? 2 plus 1 2/4 plus 3/4 plus 3/4. Okay, I'm going to just do my whole numbers first. 1, 2. Denominator stays the same, stays 4. 2 plus 2 is 4. Plus 3 is 10. Okay, I have to simplify that. 4 goes into 10 2 times, so that makes this a 4. These move 2 fourths, which equals 4 1/2. That would be my perimeter. And it depends on what units. Here, let's do inches. I didn't do that. Inches. So I always make sure we add whatever we have as far as your units is important. Okay, now area. This is a little different. You could do the straight algorithmic, which is just multiplication, which is pretty simple. 3/4 times 1 1/2. I have to convert, right? So it's going to be 3/4 times 2 times 1 plus 1 is 3/2. Multiply across. 3 times 3 is 9. 4 is 8 equals 1 1/8. And if this is in inches, it'd be inches squared. Remember, it's a square. We're talking about squares. All right? So that's that. But let's go back a little and let's just visualize area. I'm not going to go too much into perimeter because it's just adding the sides. I think you guys can handle that. But let's just, if we're looking at perimeter, and let's say I have 5 and 4. Okay, I can look at it like this. I'm going to do this 1, 2. So I have 5. 1, 2, 3, 4, 5, and then 4. 4. 1, 2, 3, 4. Now, if this is, let's just do feet. Now I can just count these up to get my area, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My area is 20 feet squared. Okay? Now that's area. That's the concept of area. It's the surface. It's up. It's length times width or height times length. Depends what you want to do. But that's the concept of area. Now, when we're dealing with fractions, now let's do one with fractions. Let's say I want to know the area of, we'll keep with 3/4, and let's do inches by 1/5 of an inch. Okay, so if I'm going to do an area model of that, I'm going to separate it like this. I'm going to do 5 again, 1. So 5, 1, 2, 3, 4, 5. Forgive me for not being even. And then 4. 1, 2. So 1, 2, 3, 4. Now, if we're talking about area, we got to look at what's shaded. Now we did this We did this a lot when we were multiplying fractions to figure out the answer. We did the area model. It's the exact same thing as that. So how much of this 1/5? That's just going to be these. These are shaded in. That's 1/5. Now, how much of the 3/4? Well, it's going to be 3 of these. So it's going to be okay. So what are marked by both is going to be the area. It's 1/5 by 3/4. So 1/5 by 3/4 is going to be 1, 2, 3. That's going to be my numerator. And then what's my denominator? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this is inches squared. So 3/20 of an inch squared would be 1/5 of an inch by 3/4 of an inch. So that's our concept, is that we are multiplying fractions. That's what's different here when we're dealing with area. Now, some of the models, I'm going to see, they don't have that complicated model. That's kind of hard. So it's pretty straightforward. If you get the algorithmic problem, this should be pretty simple. Let's do one more area problem, just so it's clear. Remember, you can always rewatch these videos, but let's just do, and this one is in the book. It's rectangle D in the book, and it is, let me make sure I got that number right. It is 2/3 of a centimeter. That's one side of the rectangle, by 4/5. 4/5 of a centimeter. Now I could just straight up multiply that and get my answer. But let's do a visual so that we make sure we understand. So I'm going to do a square, best I can, freehand. There's a square. Okay, and this is going to be a unit of 1. Okay, so if this is one thing, and I'm determining 2/3 of a centimeter by 4/5 of a centimeter. So if this is 1 centimeter, we're going to break it up just like the area model we did when we were doing multiplication of fractions. So I'm going to start at the top and do my 4/5. You know what, let's do different colors just to make this, since I brought home all these markers. 4/5 centimeters. So I'm going to do, so when I have a 5 here, I do 4 lines. That helps me do it. So I get 1, 2, 3, 4, 5. Got 4 lines separated at 5 times. Okay, so that's this. Now 4 of these are going to be shaded, but I guess I can do the shading now. So we'll just do our shading. Why not? Okay, so that much of the unit of 1 is 4/5. Now we go the other direction for 2/3. 2/3 centimeters. Now we go the other direction, 3. So I'm going to just do 2 lines to separate it into 1, 2, 3. 1, 2, 3. It's separated into 3 the other direction. Okay, so now how many of these am I going to shade? 2. So I'm going to go the other direction in green. Okay, so now to find out my answer, I count up. So I'll do my numerator first. And I don't know, it's just my habit. You can do your denominator first. My habit is to do my numerator. And remember, this is centimeters times centimeters, so it's centimeters squared. Centimeter times centimeter equals centimeter squared. Okay. Why is it squared? Think about it. We're doing 2 directions. On an axis, it'd be 2 directions, up and down. So it's squared. Centimeters this way, centimeters that way. So we square it. So I'm going to do my numerator first. And this is 1, 2, 3, 4, 5, 6, 7, 8. 8 is my numerator. Now I'm going to do my denominator. Let's do it in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Okay. 8/15. Does 8 go into 15? No. So this is a good fraction. I don't have to reduce it. So it'd be 8/15. Okay, now if I just want to continue just to double check my math. Oops. 2/3 times 4/5. 2 times 4 is 8. 3 times 5 is 15 centimeters squared. Either one of those will work. Okay, it's pretty straightforward. Good luck with it. And let me know in small groups if you have any questions about any of these lessons. Thanks.